This question is a little bit special. It's not exactly like the typical question type. So try to memorize how I analyze the question also at the same time. So they say that there is 64 households. That means the sample size is equal to 64. And then approximate beta percent of a confidence interval. This is the different result of the sample size, and then we use two lines to separate it and create a confidence interval between them, which is between 0.0915 and 0.3085. And then we use this interval to estimate the original proportion. And they ask you about the sample proportion of the household. That means our starting point to estimate the interval, and our starting point should be the middle of our interval. So part A1 is easy. If you understand what it's asking, you just simply use two boundaries divided by 2 to get the midpoint, which is 0.2. So at this point 0.2, and then we have to find the beta percent here, talking about the area covered by these two boundaries. In other words, that means we are calculating the area of this part. It gives us some idea how we can solve it. First, we need to know the sample proportion distribution. It should follow a normal distribution with certain standard deviation. After that, we need to calculate the corresponding standard score for the upper bound or lower bound. And then you have the standard score. You can check the standard normal distribution table to get half of its area, and then you times 2, you will get beta. The population proportion is P. It's a fixed value. It's not a distribution. Every response may be a distribution. Every one response is follow a binomial distribution with the corresponding probability. That means the proportion P. That's why the sample proportion will follow a normal distribution. The mean of this distribution is unbiased. That means it should be the same as our true value, the population proportion. The keyword is about the variance. We learn about the binomial distribution. The variance should be P times 1 minus P and then divided by N. Because it's not only one time, but this sample repeated for 64 times. That's why we have divided by N. Now, a very important thing is we have the variance, which means that we can get the standard deviation. Once we get the standard deviation, we can get the corresponding standard score. So we get the standard deviation is equal to P, which is 0.2, our estimated P, and then 1 minus P, 1 minus 0.2, divided by the number of samples, 64, and the whole thing square root, because this is variance, this is SD. We get 0.05. So that means the difference here is how many times of 0.05? The corresponding standard score is 0.3085 minus the mean and then divided by the SD. 2.17 times, which means that this position is 2.1 SD time away from our mean, and it gives us the area from the table. Therefore, the area is equal to 2 times 0.4850, which is obtained from the standard normal distribution table. That means 0.97 times. Our confidence interval covers the 0.97 area of this whole thing. In percentage form, that means 97%. They ask us about beta percent. So if we just compare the beta part, it's referred to 97. You should write beta equal to 97 but not 0.97. And be reminded that in your exam you don't need to write down the distribution like this. It's just for my explanation. In part B, they ask us to find the least number of households such that at least one of these households who keep pets is greater than a certain amount. So think carefully, is the sample size is no longer 64, but they are asking for a suitable n. And that n need to fulfill this requirement. And then you have to think what kind of distribution it is. We repeat the same thing for many times, for n times, and then the response is yes or no. So this is binomial distribution. We let x be the random variable that are the number of households who keep pets, and then it's follow a binomial distribution. If we repeat it by n times, we don't know how much it is, and the corresponding probability to success is 0.2. So we are asking for the probability that at least 1 larger or equal to 1. That's the required probability. So based on what you learn, of course, list out our outcomes: 0 household, 1 household, 2 household, 3, 4, until n household. And then we are talking about this part. So we use the basic strategy, we use all the possibility, and then we subtract the only rejected case here. Be careful whether you should reject one or not. Think carefully. So continue. Within n times, all fail. So this is among n, we get 0. Successful time is 0, power 0. And then the fail time is power of n. That means 1 minus 0.8 power of n. They say that the given condition is the required probability greater than this amount. So 1 minus 0.8 power of n is greater than 0.999. Just handle this exponential inequality quickly. Take log on both sides. Therefore, both sides divided by natural log 0.8. But beware that natural log 0.8 is a negative value. So once you take this action, the direction change, reverse. N is larger than 30.95655 something. So the least value of n to fulfill this requirement is 31.